Greetings. It's a little short video to help you work this particular problem. So numbers are slightly different from the numbers that appear in the problem, so make note of that. Assume that scores on the verbal portion of the GRE graduate record exam follow the normal distribution with a mean of 153 and a standard deviation of 6.8, while the quantitative points on the exam have scores that follow the normal distribution with a mean of 156 and a standard deviation of 6.97. Use this information to answer the following. Find the score of a student who scored in the 80th percentile on the quantitative reasoning section of this exam. Okay, so first thing is we got to make sure we use the proper distribution. So we're talking about which one? We're talking about the quantitative reasoning exam. Okay, so the quantitative exam, what was the mean and the standard deviation for the quantitative reasoning? Say why the quantitative portion of the exam scores, so that was the verbal. Oh, here's the quantitative. Okay, so it's got a mean of 156 and a standard deviation of 6.97. So that means that this distribution is assumed to be normal with the mean of 156 and a standard deviation of 6.97. Okay, so as usual, whenever you're working a situation like this, you should draw yourself a picture that represents what they're asking. So they want to know the score for somebody who is in the 80th percentile. All right, so if we say we're normally distributed, and we know that the mean of the scores is equal to 156, and the standard deviation is equal to 6, let's make that look like a 6, 6.97, and they want to know what is the score for the 80th percentile. What that means is they want to know the position on the axis right here, on our x-axis, such that this shaded region down below right here, this total area down in the lower part right here, is 0.8 or 80%. Okay, so in other words, the shaded region is 80%. So those who scored in the 80th percentile means that 80% of their peers scored less than them. All right, so to do that, we're going to have to use the command on the calculator that does what's referred to as the inverse norm. Okay, so let's get a fresh screen here and let's go get our calculator up. So to do that, we're going to go back into the distributions menu, go second vars to get into our distributions. Let's try that one more time. Second vars, there we go. And we see INVNorm or inverse norm. INVNorm gives us the inverse normal. In other words, you give it an area from the left and it will give you back the position on the axes. We have to give it not only the area though, but you got to tell it which distribution you're working in, so you need to give it the mean and the standard deviation also. So let me put it over here so we can make the screen a little bigger for you. So that means, show you a bigger screen. Widen things up just a smidge there. There we go. So if we go in and we grab option number 3 here, inverse norm, the area that we have is 0.8. And then we need to know what was the mean and the standard deviation. Okay, a quick reference back here. Let's go back and take a look at our slide. Let's see, the mean for the qualitative was what? Was 156 and the standard deviation was 6.97, right? Okay, so let's go back and bring our calculator back here. So I'm going to put 156 and then put in 6.97. Okay, so again, I got those simply by looking at the problem here, realizing that my mean was 156 and my standard deviation was 6.97. Okay, cool beans. Okay, so once we do that on the not so fancy calculators, it'll come up on your home screen with INVNorm and you have to type in putting commas in between the numbers. Recall the comma comes from right above your 7. That's where the comma key resides. Okay, and always be sure and put off the close parenthesis. Okay, hit an enter and we get 161.8661. We're going to go ahead and round that to 2 places. We'll go 161.87 if we round off correctly. So that tells us that this value right here at that point was at, let's go back to a quick peek at the calculator. What was it again? It's at 161.87. 161.87. Okay, so hopefully that made sense. Now, the key thing here is that notice they gave us a percentile. When they give you a percentile, and then what that means is they're giving you an area, and you need to give it back a position on the axes. Okay, let's go ahead and take a look at another one of these. Okay, so assume the scores in the verbal portion of the GRE record exam have a mean score of 151, standard deviation is 7, and the quantitative portion of the exam has scores fall a mean of 153 and a standard deviation of 7.67. Okay, so notice they changed up the values on us on our distribution, so make sure you take note of that. And they say find the verbal score that scored worse than 70% of the test takers in the verbal reasoning section of the exam. Okay, so let's go ahead again. Let's see if we can decide what distribution we're working in, and let's draw a picture of that. Okay, so this is normal OC. What we were working with? Oh, the verbal reasoning. Okay, so the verbal portion of it had a mean of 151. Must have been a different administration of the exam, and a standard deviation of 7. So that means this mean right here is at 151, and we got a standard deviation of 7. Okay, so find a score of a student who scored worse than 70% of the test takers in the verbal reasoning. So what that would mean is if we came down here, it means that what, 70% of the folks are above them. In other words, that area is 70% right there. Why? Because they scored worse than 70% of the test takers. Poor person. Time to take it over, right? I don't want those scores. Let me take it again. Okay, and so again, the horizontal axis represents test scores, and we want to know what their test score was. So we're looking for the position on the axes there. Okay. Now the problem is that INVNorm, it requires that you give it an area from the left. In other words, it's the left side area, okay? And then of course you got to give it mu, and you got to give it sigma. So what it wants, what it's looking for from you is, let me change my color here, it wants this area right here. In other words, the area that I'm going to input into my calculator has got to be that red area right there, okay? So if I'm going to put in an area in here for INVNorm, I'm going to have to give the area the red side. Well, actually, I don't want to go to blue right away, did I? Let's stay red. We know that that's going to be what, 30%? So if I'm going to give it the left area, then that means that the command I'm going to enter into the calculator is INVNorm 0.3, or 0.3, let's put the 0 there, and then 151 by 7. Okay, let's give that a go. So let's clear this out. Shut my pen off first, always works better. Let's go second distribution. Let's go INVNorm. And this time my area is 0.3 or 0.3. My standard deviation, let's go remind ourselves real quick what the standard deviation and the mean were. They're 153, 151 and 7, okay? Be sure to get the right numbers in there, it'll totally mess things up. So it's 151 and 7, and then since I'm on the fancy calculator, we're going to go to paste. If you're on an old school one, you got to put in the 0.3, the 151, and the 7 into the command after it enters the home screen. And an enter, and that person scored 147.33. So what we got back here was, let's get my pen turned on. What was it again? Let's take a look at the calculator one more time. It was what, 147.33. Okay, so that means this score on this axis right here, right there, same thing, is what, 147.33, and what they're telling you is that 30% of your peers scored worse than you and 70% of them scored better than you. Okay, hopefully that helps. Again, give me feedback. Always willing to do requests.